Hey, welcome to Tricksaw. Today we'll be discussing an AP Physics 1 concept of circular motion. We'll be doing this by working through a practice problem. So let's go ahead and get started. A sports car of mass m equals 1,000 kilograms is driving on a circular racetrack with a radius of r equals 40 meters. The car accelerates to a speed of v equals 15 meters per second while negotiating the turn. Let's start by illustrating what we already know. We know that there's a circular racetrack, and somewhere on that racetrack, we have a car. What we also know is that the racetrack has a radius of 40 meters. And also, we're told that the car at this point is traveling at a velocity of 15 meters per second tangent to the path. Let's read part A of the question now. Calculate the net force acting on the car when it is traveling at 15 meters per second. Whenever we're dealing with a question that's asking about net forces, we always want to start by drawing a free body diagram. So we can draw this rectangle to represent our car. Now let's think, what forces are acting on the car at this point? Well, when we're dealing with any kind of circular motion question, there's always a centripetal force, which means there's a force towards the center of the circular path. And why is this? Well, if we think about a circular path, if an object is moving at a circular path with the same speed, the velocity is still changing because velocity is a vector value, which means direction is important. So because the speed is the same, but the direction is changing, the velocity overall is actually still changing. And any time velocity is changing, this means that there is an acceleration. In the case of circular motion, the acceleration is towards the center. So that means that there is a centripetal force. And just like any other force using Newton's second law, the centripetal force is equal to the mass of the object times the centripetal acceleration. And there's actually a formula that you need to know for centripetal acceleration. For an object in circular motion, the centripetal acceleration is equal to v squared over r. And in this case, that's equal to 225 over 40. And now we can actually solve for the centripetal force by plugging in our values. Centripetal force is equal to 1,000, which is our mass, times the acceleration, which is 225, over 40, and we can get an answer of 5,625 newtons, because force is in newtons. And so the force that is centripetal is 5,625 newtons, which is actually the only force acting on the car at this point, which means our final answer for A is 5,625 newtons, because that is the net force. Now we can move on to part B of this question. Assuming that the coefficient of static friction between the tires in the track is mu equals 0.6, calculate the maximum frictional force available to keep the car on the track. Determine if the car can maintain its speed without skidding. So the first thing that this question is asking is the maximum frictional force. And in physics, the formula for the frictional force is equal to the normal force times mu, which is the coefficient of friction. And in this case, we can find the normal force because it's the same thing as the weight, mg, which is equal to 1,000 times 9.8, which is 9,800 newtons. Okay, so now we can actually find the force of friction because mu is given to us. The force of friction is equal to 9,800 newtons times 0.6, which is equal to 5,886 newtons. So that's actually the first part of our answer to B. 5,886 newtons is the maximum frictional force. But the question also states, determine if the car can maintain its speed without skidding. In physics, an object skids in this scenario if the centripetal force is greater than the maximum frictional force. And we can just compare our numbers here. So our centripetal force is 5,625 newtons, and our maximum threshold for frictional force is 8,886 newtons. And we can find out that our threshold is greater than our actual centripetal force, which means that the car is not skidding. It's also important to note that what's actually causing the centripetal force in this scenario is friction, because the centripetal force is caused by the tires rubbing against the road, which will push the car inwards. Thank you for watching this video. If you have any questions or any other AP Physics 1 concepts that you'd like me to discuss, please just leave a comment down below. Thank you for watching, and as always, make sure to subscribe.